Welcome to a new episode of AI Research Radar, where we showcase the most cutting-edge developments in the field of artificial intelligence. Join us as we shine a spotlight on the latest advancements and breakthroughs in AI research. From machine learning to natural language processing, AI Research Radar covers it all to keep you informed on the forefront of AI innovation.
The paper titled GROUNDHOG, Grounding Large Language Models to Holistic Segmentation, presents a new framework named GROUNDHOG, aimed at improving the text output of large language models by incorporating pixel-level phrase grounding across a wide range of semantic granularities. The methods proposed in the paper include 1. Masked feature extractor. The first method proposed is a masked feature extractor. This extractor takes an input image and a set of class-agnostic entity masked proposals, and transforms each mask's features into visual entity tokens for a multimodal large language model (MLLM) backbone. The MLLM then links groundable phrases to unified grounding masks by retrieving and merging the entity masks. 2. Building entity features from masks. The authors suggest conditioning the entity features solely on the binary masks, without using any embeddings from the mask proposal model. The mask corresponding to each entity is used to extract patch features from pre-trained vision foundation models, such as CLIP and DIN-of-2, through a convolutional mask pooling layer. The pooled features are then fed into a multi-layer perceptron (MLP) network to align with the input embeddings of the MLLM. 3. Language grounding to entity segmentation. The authors introduce a pair of grounding tokens OGRD and a GRD to indicate the start and end of groundable phrases. The representation of each groundable phrase, termed as the grounding query, is obtained by adding a GRD and a GRD-S output embedding from the last transformer layer of the MLLM. The representation is then used to retrieve the entities that the phrase should be grounded to. 4. Towards holistic entity masked proposals. The authors propose an enhanced MASK-2 former model, MASK-2 Former Plus, as their default mask proposal network. This model is designed to detect regions at multiple granularities, leading to a holistic coverage of visual semantics. 5. Training on M3G2 dataset. The authors curated a multimodal multigrained grounding M3G2 dataset consisting of 2.5M text-image pairs for visually grounded instruction tuning. The dataset consists of 36 subproblems derived and augmented from 27 existing datasets. The authors present extensive experiments on vision language tasks that require grounding, including grounded language generation with minimal object hallucination, language-guided segmentation, visual question answering with answer grounding, and referential dialogue with spatial pointer inputs. The experimental work conducted to validate the methods proposed in the paper is divided into several parts. 1. MASK-2 Former Plus implementation. The authors developed an upgraded version of the MASK-2 Former model, named MASK-2 Former Plus, designed for multigrain segmentation. This model was trained on a diverse dataset created by merging annotations from various sources, including COCO, LVIS, Entity-R v2, Pascal, PACO, MHP v2, and TextOCR. The model's capabilities were assessed on 1,000 images from validation splits from for grounding benchmarks, RefCOCO+, PhraseCut, ReasonSeg, and TextVQAX. 2. GROUNDHOG model training. The GROUNDHOG model was trained on the M3G2 dataset, which consists of 2.5M text-image pairs for visually grounded instruction tuning, consisting of 36 subproblems derived and augmented from 27 existing datasets. The model was trained using the Vicuna 7B model as the base LLM, and the OpenAI CLIP at 336 model and DIN-of-2 PELT14 reg pre-trained checkpoints for the vision encoders. 3. Generalist in grounded vision language tasks. The authors evaluated GROUNDHOG's performance on various grounding tasks, including language grounding to segmentation, grounded language generation, and spatial prompt understanding. The model was tested on several benchmarks, including RefCOCO, Flickr 30K, Entity, PNG, TextVQAX, PointerQA twice, and V7W. 4. Trustworthiness and transparency. The authors also evaluated the model's ability to reduce object hallucination and improve explainability and diagnosability. The model's performance was assessed using the POPE benchmark, which includes binary questions about object existence. The authors also conducted case studies to illustrate the model's explainability and diagnosability. 5. Ablation studies. Finally, the authors conducted ablation studies to validate their design decisions. They compared the effectiveness of different mask proposal models, entity features, grounding query representations, and evaluation input resolutions. The ablation studies were conducted on a subset of the M3G2 dataset that includes RefCOCO+, Flickr 30K, and TextVQA.
This is AI Research Radar. Now, we will be delving into the next paper on our agenda.
The paper titled, Leave No Context Behind. Efficient Infinite Context Transformers with Infini-attention. Presents a novel method to scale transformer-based large language models, LLMs, to infinitely long inputs while maintaining bounded memory and computation. The primary component of this approach is a new attention technique known as Infini-attention. Infini-attention. Infini-attention integrates a compressive memory into the standard attention mechanism and combines both masked local attention and long-term linear attention mechanisms within a single transformer block. It reuses all the key, value, and query states of the standard attention computation for long-term memory consolidation and retrieval. Unlike the standard attention mechanism, which discards old key value (KV) states, Infini-attention stores these states in the compressive memory. These stored values are then retrieved using the attention query states when processing subsequent sequences. The final contextual output is computed by aggregating the long-term memory retrieved values and the local attention contexts. Infini-transformer. The Infini-transformer model operates on a sequence of segments and computes the standard causal dot product attention context within each segment. Instead of discarding the attention states of the previous segment when processing the next one, as in the case of local attention, Infini-transformers propose to reuse them to maintain the entire context history with a compressive memory. Compressive memory. The compressive memory primarily maintains a fixed number of parameters to store and recall information with bounded storage and computation costs. New information is added to the memory by changing its parameters with the objective that this information can be recovered back later on. Scale dot product attention. The multi-head scale dot product attention, especially its self-attention variant, has been the main building block in LLMs. A single head in the vanilla multi-head attention computes its attention context from a sequence of input segments. Memory and effective context window. The Infini-transformer enables an unbounded context window with a bounded memory footprint. It has a constant memory complexity for storing compressed context in each head in a single layer, while for the other models, the complexity grows along with the sequence dimension. The authors of the paper conducted a series of experiments to validate the effectiveness of their proposed method, Infini-attention. The experiments were designed to test the model's performance on tasks involving extremely long input sequences. Long context language modeling. In the first experiment, the authors trained and evaluated small Infini-transformer models on PG19 and ArXivMath benchmarks. The setup closely resembled that of memorizing transformers. All models had 12 layers and 8 attention heads of dimension 128 each and feed-forward networks, FFNs, with a hidden layer of 4096. The Infini-attention segment length was set to 2048 for all attention layers and the input sequence length to 32768 for training. The authors also increased the training sequence length to 100K from 32K and trained the models on the ArXivMath dataset. LLM continual pre-training. In the second experiment, the authors performed a lightweight continual pre-training for long context adaptation of existing large language models, LLMs. The pre-training data included the PG19 and ArXivMath corpus as well as C4 text with length more than 4K tokens. The segment length was set to 2K throughout the experiments. 1M passkey retrieval benchmark. In the third experiment, the authors replaced the vanilla multi-head attention, MHA, in a 1B LLM with Infini-attention and continued to pre-train on inputs with a length of 4K. The model was trained for 30K steps with a batch size of 64 before fine-tuning on the passkey retrieval task. 500K length book summarization, BookSum. In the fourth experiment, the authors further scaled their approach by continuously pre-training an 8B LLM model with an 8K input length for 30K steps. They then fine-tuned on a book summarization task, BookSum, where the goal is to generate a summary of an entire book text. Results. The results of these experiments demonstrated that the Infini-attention model outperformed the baselines on the long-context language modeling benchmark and book summarization tasks. It also showed promising length generalization capability.
This is AI Research Radar. Now, we will be delving into the next paper on our agenda.
The paper titled GOEX, Perspectives and Designs Towards a Runtime for Autonomous LLM Applications, presents several innovative methods to tackle the challenges associated with integrating large language models, LLMs, into real-world applications and services. The primary focus is on the concept of post-facto LLM validation and the creation of a runtime for executing LLM actions, known as the Guerrilla Execution Engine, GOEX. Post-facto LLM validation. This method involves validating the accuracy of a proposed action after the output has been generated, as opposed to before, pre-facto validation. The authors argue that post-facto validation is often simpler and more efficient. To facilitate this, they propose two main strategies. Undo feature. This feature enables users to reverse the effect of an output generated by an LLM if it does not meet expectations or requirements. Damage confinement. This strategy involves setting a limit on the potential risk or damage that can be caused by an action generated by an LLM. This is particularly useful when an action cannot be reversed. Guerrilla Execution Engine, GOEX. GOEX is an open-source runtime specifically designed to execute LLM actions. It aims to strike a balance between safety and utility, and it utilizes readily available off-the-shelf software components. GOEX supports a variety of actions, including RESTful API requests, database operations, and file system actions. Each type of action is handled in a unique way, with specific strategies for mitigating risks and ensuring safety. RESTful API calls. GOEX securely manages user secrets, provides a mechanism for storing secrets, and generates actions and undo actions. It also conducts a reversibility test to confirm that the generated reversal operation effectively reverses the original operation. Database operations. GOEX takes advantage of the mature transaction semantics offered by databases. It provides two options for reversibility, using a reverse database operation, reversal, or using the traditional ACID transaction guarantees of the database, versioning. File systems. GOEX employs Git version control to track the directory tree and provide reversibility. It also conducts a reversibility test similar to the one used for RESTful API calls. The goal of these methods is to simplify and enhance the safety of human collaboration with, delegation to, and supervision of autonomous LLMs in the future.
Thank you for joining us for this episode of AI Research Radar. Be sure to stay tuned for our next episode where we will showcase the latest innovations in AI research. If you enjoyed the content, please consider subscribing and liking the video.